Hello everyone. Welcome to our new course on augmented reality, where we are going to build augmented reality applications using the latest version of Unity, that is Unity 6.5.5, and the same technique can be adapted even to the upcoming Unity 7 version. Today, we are beginning a journey into one of the most exciting areas of interactive technology. During this course, we will not merely study augmented reality as a concept. We will design AR experiences, build working applications in Unity, test them on mobile devices, and examine how AR can be used to solve real-world problems. Learning AR development can also help you expand your creative and technical portfolio and prepare for opportunities in the wider extended reality industry. Now, first of all, let us understand what is augmented reality. Augmented reality, commonly called AR, is a technology that overlays a digitally created content over the user's real-world environment. When you use an AR application, you continue to see the physical world around you through a camera or a transparent display. However, digital elements such as text, images, animations, audio, videos, or three-dimensional models are added to that view. For example, imagine pointing your mobile phone to a classroom desk and seeing a three-dimensional solar system appearing on the surface. The desk is real while the planets are digitally generated. The combination of these two creates an augmented reality experience. AR does not completely remove your physical world. Instead, it augments or adds to your experience of reality. Now, let us understand what is AR, VR, MR, and XR. Augmented reality belongs to a broader field called as extended reality or XR. XR is an umbrella term that includes augmented reality, virtual reality, and mixed reality. Virtual reality or VR replaces the user's view or the physical world with a computer-generated virtual environment. When wearing a VR headset, users may feel as if they have entered a completely different place. Augmented reality keeps the real world visible and places digital content over it. Mixed reality or MR is a broader term for experience in which physical and digital content are blended more deeply. In mixed reality, digital objects may appear to understand and interact with physical surfaces, spaces, and objects. We can think of these technologies as existing on a spectrum. At one end is the complete physical world. AR remains closer to the physical world. At the other end is complete virtual environment represented by VR. Mixed reality can cover a wide range between the two. Now, let us understand why this AR is a special medium. AR is different from ordinary digital media because the user's physical environment becomes part of the experience. In a conventional mobile application, the content normally remains inside the screen. In AR, digital content appears to occupy the space around the user. A table can become a game board, a wall can become a portal, a printed picture can trigger an animation, a human face can become the surface for a digital mask, a classroom can become an interactive laboratory. Because of this connection between the physical and digital worlds, AR can make information more visual, interactive, contextual, and memorable. However, we must not use AR simply because it is impressive. As developers, we must ask whether AR genuinely improves the experience. We must also consider safety, accessibility, lighting, available space, device performance, camera quality, tracking, stability, and user comfort. Now, let us understand the AR application landscape. AR application can be classified into several major categories. The first one we call it as face filter AR. Face filter application detects a person's face and identify facial features such as the eyes, nose, mouth, and overall face shape. The application can attach digital content to those features. Example include virtual masks, makeup, hairstyles, glasses, hats, and animated characters. Social media filters are common examples, but face tracking can also be used in virtual product trials, entertainment, education, and communication. During this course, we will first create a simple face filter that places materials and 3D models on a user's face. We will then develop a more interactive experience in which users can select, customize, and visualize different pair of glasses. Now, the second type of augmented reality is called as marker-based augmented reality. Marker-based AR recognizes a predefined image, illustration, pattern, or QR code. When the camera detects the marker, the application places digital content on or around it. For example, scanning an image in a textbook can display an animated 3D model. A business card could show a portfolio video. A museum image could become animated. Product packaging could launch an interactive demonstration. In our course, we will create marker-based application that recognizes a particular image and projects an interactive three-dimensional model over it. Now, the third type of augmented reality application is markerless AR. Markerless AR does not require a specific printed image to position content. Instead, the application uses the device, camera, and sensors to understand the surrounding environment. It can detect flat surfaces such as floors, tables, and walls and place digital objects in the physical space. Furniture preview applications are a useful example. They allow customers to see how a chair, table, or other product appear inside their home before purchasing it. In this course, we will create a plane detection application. It will identify a flat surface and allow the user to place or spawn a virtual portal on a desk, floor, or wall. Now, the fourth type of AR is the location-based AR. Location-based AR uses information such as GPS location, compass direction, and sometimes environmental scanning to determine where the content should appear. Tourism application can display information about nearby landmarks. Astronomy applications can identify stars and planets based on the user's location and the direction of the device. Games can place characters or activities at real geographical locations. Location-based AR therefore connects digital content not only to what the camera says, but also to where the user is physically located. Now, let us understand how we can evaluate these AR experiences. As we explore different AR applications, I want you to think like both as a user and a developer. Ask yourself, which feature appears repeatedly across AR applications? For which problem, AR is an appropriate solution? Does AR make the experience more useful, understandable, or engaging? Are there situations in which a normal mobile application, website, animation, or video would work better? Now let us understand what are the strengths of AR. What are its technical and practical limitations? A successful AR developer must understand not only how to build an application, but also why the application should use AR. Now, let us just review what we are going to build in this course. Our learning journey will be divided into 4 major projects. At the first project, we will prepare the AR development environment, create our first AR application, deploy it to a compatible mobile device, and verify that the development setup works correctly. In the second project, we will work with face tracking. We will create a basic face filter and then develop a more interactive virtual glass experience. In the third project, we will explore image recognition and environmental understanding. We will create a marker-based experience and then develop a markerless application that detects flat surface and places a portal in the user's surrounding. And in the final fourth project, we will study augmented reality experience design. We will take an existing desktop game about aliens abducting a ship and consider how its design and interaction can be adapted for mobile AR. The final project is very important because converting a conventional application into AR requires more than changing the camera. We must rethink the user's movement, physical surroundings, interaction methods, scale, safety, and overall experience. Now, who can all learn this augmented reality development? This course is intended for anyone interested in creating mobile AR experiences with Unity. You may already have experience creating filters in other applications and want to build more customized AR experiences. You may have developed traditional Unity games or simulation and now want to extend your skills into AR. You may simply enjoy using AR applications and want to understand how to create your own. Now, to start this learning process, you should have a basic understanding of Unity, including how to navigate the Unity editor, working with game objects and components, and moving around in a three-dimensional scene. If you are entirely new to Unity, complete my previous Unity profile series and that would be very helpful. Prior knowledge of Unity visual scripting is not required. Now, the next part we are going to discuss is about handheld and head-mounted AR. AR experience can also be classified according to the hardware used to experience them. In head-mounted AR, the user wears a device and views digital content through lens positioned in front of the eyes. Examples include Meta Ray-Ban glasses, Microsoft HoloLens, Magic Leap, and Google Lens. The most popular is right now Ray-Ban Meta glasses. Head-mounted AR is commonly associated with specialized professional, industrial, medical, training, and enterprise applications. This course will concentrate on handheld AR. In handheld AR, user hold a mobile phone or tablet, points its camera at their environment and view the combined physical and digital scene on the device screen. Handheld AR is highly accessible because many people already own a compatible smartphone. It is therefore an excellent starting point for learning AR development. Now, to use this, the mobile device requirements that we need is to build and test AR applications. You will need a compatible Android or iOS mobile device and a suitable data cable for connecting it to your computer. Your device must support the AR features required by the project. Compatibility depends not only on the operating system version, but also on the particular phone model and its support for technologies such as Google ARCore and Apple ARKit. Now, for you to complete this course, you should have an iPhone X or later running iOS 11 or later OS or an Android device running Android 7 or later. However, before beginning the development, we will verify the current requirements of Unity, AR Foundation and ARKit for the versions and devices we are actually going to use. This is important because AR software, package requirements, operating systems and list of support devices continue to change. Now next, for computer and deployment purposes, your computer operating system affects which mobile platforms you can build for. A macOS computer can be used to develop and deploy Unity applications to both Android and iOS devices, provided the required development tools are installed. A Windows computer can be used to develop and deploy applications to Android devices. However, creating a final iOS build requires Xcode, and Xcode is available only on macOS. Therefore, if you have only a Windows computer and an iPhone or iPad, you will not be able to complete the normal local iOS deployment process directly. For our practical work, we must confirm that every student has a workable combination of computer, mobile devices, USB cable, require drivers and platform development tools. And now coming into the role of Unity in AR development, Unity gives us a visual environment for constructing interactive 3D experiences. For mobile AR, Unity can work with technologies such as AR Foundation. AR Foundation provides a common Unity framework through which we can assess features implemented by ARCore on Android and ARKit on iOS. These features can include device and camera tracking, face tracking, image recognition, plane detection, ray casting and object placement, environmental understanding, light estimation, anchoring virtual content in physical space. Not every feature is identically supported on every platform or device. Part of this professional AR development is testing carefully on the actual target hardware. Now, the approach to the course is that throughout this course, we will learn through experimentation and practical development. We will examine existing AR experiences, create projects in Unity, configure the required packages, connect mobile devices, build applications, identify errors, and improve your designs. You should expect some technical challenges. AR development involves Unity mobile operating systems, development packages, cameras, sensors, device permissions, platform-specific settings, and physical testing environments. When an AR object does not appear correctly, the reason could be lighting, tracking, scale, detection, device compatibility, package configuration, build setting, or application permission. Learning how to investigate these problems is an important part of becoming an AR developer. By the end of this learning journey, you should understand the foundation of mobile AR and be able to create several different kind of AR experiences in Unity. More importantly, you should begin thinking like an AR experience designer. Do not ask only, what digital object can I display? Instead, ask, how should the digital object relate to the physical environment? Why is AR the right medium for this experience? And how will the user discover and interact with the content? What happens when tracking is lost? Is the experience safe, understandable, accessible, and useful? Today, we are not simply building another Unity project. We are learning how to connect digital imagination with the physical world. Welcome to this augmented reality development session.